Okay, so now I'm going to do a review of the chapter on distributed consensus. Uh, so you know what to expect and what kind of questions to expect from this chapter in your final exam. So these are some of the examples of distributed consensus. Now you do need to know how to define a distributed consensus. So every process decides with an initial value, and they receive a set of initial values that were decided on by other processes, and this becomes the input for each process. Based on these inputs and the initial value, they all decide on the same output value. Okay, so that's a simple definition. You should be able to describe the problem of distributed consensus. You could use the figure shown on this slide in order to describe a problem of distributed consensus as well. Now, so these are the three things which actually specify the problem of distributed consensus: termination, agreement, and validity. You don't need to remember these three terms, but you do need to know how to describe the problem of distributed consensus in your own words. Now, moving forward, you should be able to describe the Byzantine general's problem. Okay, give a basic definition of what a commander is, what a lieutenant is, and what a commander can do, what a lieutenant can do, what is expected. So you should be able to define Byzantine general's problem in your own words. Now, moving forward, you can have a problem-solving question like the one on the slide here. You're given 4 processes, let's say, and you're given the input value, okay, of each of the selected by each of the processes. And after the input value is shared with all the other processes in the system, every process ends up with a vector of values. So based on the vector of these values, you decide on the input, you decide on the output value. So you will be asked, you may be asked a question where you know what you decided on, what is the set of input values you've seen, and you can be given a function such as the majority vote, okay, in order to decide the output value, and you should be able to give what the output value for each of the processes is. Okay, so you can expect a problem-solving question of that type. Now, moving forward, you have to know what the two interactive consistency specifications are. You have to be able to define each of the interactive consistency specifications. That every loyal lieutenant must decide on the same order, and if a commander is loyal, then all the lieutenants have to receive whatever order was sent by the commander. So you have to be able to describe these two. There was a question on your homework as well to list the two interactive consistency specifications. So you need to know both of these. Now, moving forward, you should know what OM of M means. You should know what the definition of that is. Um, Moving forward, you should be able to give the impossibility result when there are three processes and one of them is a traitor. Okay, so you have to show how the other lieutenant that is not a traitor cannot decide if the commander is the traitor or the other lieutenant is the traitor. So you have to show the two cases and prove how it's not possible to come to a consensus in a problem with three processes where one of them is a traitor. Now, moving forward, the thing that you need to know from the distributed consensus is how the algorithm works, and you should be able to solve a problem where you're given some n number of processes where m of them are traitors. So you should be able to draw such a tree. So this is what is expected out of you to know for the final exam from the chapter on distributed consensus. the right final exam. For these both know the proofs of